So the next step is to get the tasks into the list. What we're going to do to make that happen is to create a custom view that will show each one of the task list items, so each element in the list. And we're going to make a list adapter, which is going to be the data provider for the list view. So let's talk about what an adapter does. An adapter is it's the instance of the class that is responsible for taking data out of a list and telling the list view that needs to display that data the answers to a few interesting questions, and also performing a few important tasks. So the list view needs to know how many items there are in the list, and so to figure that out, it asks the adapter. The list view sometimes needs to know it needs to uniquely identify each item in the list, so the list adapter is also responsible for helping the list view do that by providing an API to get the ID for each specific item in the list. And sometimes that can be an ID that you define, or that can be an ID that is just based on position or something like that. But the list adapter is responsible for uniquely identifying each item in the list. It's also responsible for getting the data for an item at a position, and for providing the list view with the view that needs to be displayed for each item that the list view asks for. So it's responsible for a lot, and it allows the data to not have to know about any of that stuff, and it allows the list view to not have to worry about those kind of details. It delegates those all off to the list adapter. So the list adapter is a pretty important part of this whole displaying data in a list. So the steps that we need to go through to accomplish the tasks that we have for this step is we need to create the list adapter. We need to implement some of the interface that defines, and then we need to create a custom view that will be responsible for displaying a single task, and then we need to return an instance of that view from the adapter on the getView call, which the list adapter is going to call, or I'm sorry, the list activity is going to call. So let's start out by creating the adapter. So I'm going to come here to my Package Explorer, and I'm going to create a new class by right-clicking this project. I'm sorry, this package inside of the Package Explorer, and go to New, and go to Class, create a new class. And I want to put this adapter in its own package so I can find that easily. The name of this is going to be just task list adapter, and its superclass is going to be base adapter. So that is enough to complete this. So the base adapter class is provided by Android as an implementation of the adapter interface, and it's a very basic adapter that just sort of provides implementation of some things underneath it, but there's also some things that we need to implement as well. So you can see that there's an error here in Eclipse, and I can hover over this base adapter class and say base adapter cannot be resolved to a type. That's weird. It didn't find it. In any case, that organize imports. Anyway, the package is for that is Android dot widget dot base adapter. There. Now we should be able to find that. Now, since we've imported that, the task list adapter says that it has some problems because it's not implementing all the methods that are abstract inside base adapter. So I'm going to come here and hover over the task list adapter class and say add unimplemented methods, which is nice. We don't have to go figure out what those are, and then a whole bunch of code gets put into my file. So here are the methods that got added by base adapter, or by implementing all the abstract methods of base adapter: get count, get item ID, and get view. So those are the ways that the list adapter fulfills its responsibility that the task list list view is going to delegate to the adapter. So what we want to do, so let's go look at where we're storing the list items right now, which is inside of the Task Manager application, which is again the application file kind of present throughout the whole application, no matter what activity is being shown. So the Task Manager application holds a list of the current tasks, which is just an array list of the type task. What I think we want to do inside the task list adapter is do the same thing. We're going to have it have a reference to that list as well. So let's have it hold a private variable of type array list. And we need to import that guy. Thinks there's a syntax. I'll just keep on typing until I can get here and get Eclipse to fix this for me. So I'm just going to have a list of tasks, an array list of tasks. Hover over this, import Java util array list, and we also need to import the task class that we created last week, com.o'reilly.android task manager tasks. Now we hold a reference to a collection of all the tasks, and that will get passed in at some point. And the best place to pass that in to the task list adapter will be the constructor. So I'm going to implement a constructor. So I can come up here to source. Generate constructors using fields is a nice little Eclipse time saver. So then that will create a constructor using all the fields that we've defined so far on the class, and we can pick and choose those. But there's one other thing that we need to pass up to the base adapter, and that is a context to deal with. So I'm also going to define. Actually, let me close this. Well, here, let's look at this because this will show us the signature up the chain. It looks like there isn't one. So we are going to need. Okay, actually I misspoke. The base adapter, there's a different adapter that needs a context. But since this base adapter is really just a simple abstract class with not a lot of implementation, we have to deal with the context. And we'll talk a little bit more about different types of adapters later on. But we're going to need this context as well because we need to construct views against a context. So I'm going to add another field here that will allow us to generate our constructor that we want. And a context. Eclipse doesn't like me doing it that way, so I have to finish the statement first, and then it will complain, and then we can import android.content.context. Again, the context is, as we sort of hinted at in earlier classes, well, for instance, an activity extends a context. A context is sort of a holder, a placeholder for a whole bunch of different things that need to happen with Android activities and views and stuff like that. And all the way up the chain, an activity is a context, and that's so we can pass in an activity here, and then we'll have a context against which we can create views and things like that, which you'll see in a little bit. So now we have these two fields that we need on the adapter. I'm going to go back up to this source menu and say generate constructors using fields. And I can say that the fields that I want to initialize this class with are the tasks and the context, the two fields that I just created here. And I'm going to say OK, and now we have a constructor, task list adapter, which will take an array list of tasks and a context and then set the fields. And now we can start to think about implementing some of these other methods. So since we have an array list of tasks, which is going to be the data managed by this adapter, can anybody guess what we would want to return from this get count method?
The size of the list.
The size is what I have here too.
That's good. There we go. That's exactly what we want to do. So the count of all the oops, I'm in Ruby mode. The count of the number of pieces of data that this adapter manages is just the size of the list. So exactly, that's all we want to return. And similarly, for get item, we want to return, given a position, we want to return the, actually I'm going to do it this way, it's kind of a nice little guard. I don't even know if this is needed, but it's kind of defensive programming. I'm going to say if the tasks are null, then we'll return null instead of blowing up, otherwise we'll get possession of the tasks. And then just for our purposes, this is totally fine to do in an override. I'm going to be more explicit about the type return from get item because we want to return a task, not just any old object. So this task list adapter is only set up to return or to deal with lists of tasks, an homogeneous collection, I think that's called. Now, for the ID, like I said when I kind of went over this a little bit earlier, the ID really only needs to uniquely identify the items in the list. It doesn't need to be anything special like a database ID or something you may find in some external location. So that's good enough for me because I know that tasks are not going to be duplicated throughout the list to just return the position here. And that's good enough to uniquely identify any item. Now this last bit, the get view, we're going to come back to that in just a second. But that is where the adapter is responsible for displaying or for getting an instance of the view that the list view will display for each individual item when it's asked for. So let's see, what's the next thing to do? I'm going to start wiring up what I think the view should look like, and then we'll come back to this get view and wire up the code that will make that actually get called. So, well, first let's look at what it should look like inside of the slides. So we want, as you can see here, there's only one item in the list, and that list item should look like just sort of a bit of text over there on the left, left aligned, which is the title of the task, and then on right aligned up against that is the checkbox that will display to let the user know whether or not they've completed a certain task. So I'm going to first create that layout inside of resources layout. I'm going to create a task list item file. So I'm going to go right click that, say new file, task list item, I'll call it .xml. Okay, got some complaints there that aren't really important, but inside the XML I want it to look like this. In the interest of time, I'm going to copy and paste something. Actually, let me start out like this so I can talk about this in the right order. I'm going to paste the insides of the file first. There. Here's what I want the insides of this file, of this container, to look like. The first item. I'm showing you here another instance of this text, this use of sort of a magic ID or an ID that's been defined before by Android. And this is kind of in a different way. It's defined against this Android :ID type of identifier, which is slightly different than what we saw before. Basically, this component, this checked text view component, has already been defined and is used by the Android system elsewhere in its applications, and this is what I've got out of different forum posts and stuff. I'm not really sure where I found this first, but this is the easiest way to display exactly what we want to display here, a label and a checkbox. So instead of doing that, we could manage a checkbox component with some text and make sure that the two don't overlap and all that kind of stuff, but there is a component that's sort of already used that does that stuff for us, and it's called a check text view. And what's weird about it is that there's this check mark attribute on here that All right, let me kind of dive into this explanation because this is weird, and I'm not really sure of a better way to explain this to you other than this is this Android attribute type of a notation with a question mark in front of it is it looks up dynamically an attribute named list choice indicator multiple in a list of attributes that Android keeps about the system up in the innards of the SDK. I don't really know where to get a list of these attributes unless you check out the source code for the Android SDK, which we'll be doing much later in our classes. But basically, I found this online somewhere, I think, and then and spelunking around in the code a bit, I was able to understand how this all worked out. But basically, what I'm doing here is just using this check text view component, which is exactly what we want, which has a label and a checkbox, and this is the way to get the check mark to display it correctly. And we're going to center it vertically, which will make it not sit up against the top, and the layout width is fill parent, and the layout height is wrap content. So hopefully that's not too weird for anybody. Doesn't weird anybody out too much. But this is the way to get that component set up the way that we want. So now what we could do to make this, since this is really all we want on the screen, we could use something like a linear layout or something to contain this component inside of it. But there's some other things that we need to do programmatically to this view, like for instance, later on when we store whether or not our particular task list item has already been completed or checked off, we need to change the checked attribute of this check text view to make the checkbox come on right away. So there's a few things we need to do programmatically, and the way we're going to do that is instead of defining something like a list or like a linear layout or relative layout or whatever here, we're going to define a custom layout. And the way that we do that is just what you see here. I'm going to surround the component that we have here from line 7 to 12 now with a custom XML tag, which points at a custom view class that we're about to create. And you can see that the way that you do that is by putting the fully qualified path name to the class that you want to use, and that needs to be an instance of view. So we're going to go create this in just a second. And you can see that I have this orientation attribute on here, so that should hint to you that the task list item needs to be an instance of view to be a something that can sit up here as a tag. But since I have this orientation, that should hint to you that the instance of view that we're going to use is a linear layout, and then layout width and layout height are fill parent. So let's go and create that class. So inside of that may be a little bit weird. Let's stop to see if there's any questions about what I'm doing so far, and I'll just tell you if they will be better answered by going further in the code or not. But is anybody interested in anything that they see here?
Tony, I would be very interested if you could just give a quick summary of, again, what is this view that you're building specifically? Is it for people to enter the tasks, or is it for each task in the list?
It is for each task in the list. So it's just this view to display a task. One individual task in the list of all those tasks.
Okay. And so because we want to put text, our own text, that's why we're having to create a custom view?
Well, no, just to make it easier on us, because what we could do instead is create a text view and a checkbox component. So I could have a text view here and then have like a checkbox component here. I think it's called checkbox. And then I could manage the layout to make sure, like the text view, when the text of the task got long, it didn't overlap the checkbox or push it off to the side. I could do some more work to do that, and I think that could be accomplished by a more complex layout than just the linear layout. But what I found by looking at how Android applications that use the list view with a checkbox in it accomplish that, they use this component, which is exactly what we want. So I just decided to use this one instead. And whenever you run into this problem in the future, you'll have the code, and then you'll know that you can use this just the same way that I have. And so you can sort of suspend disbelief about this crazy sort of syntax here on line 12.
So why is the orientation horizontal? Shouldn't it be in portrait mode?
Well, no, the choices here would be horizontal or vertical. But since there's only one component in here, it really doesn't matter. I think that may be sort of a legacy. So let's say vertical, same difference. Because there's really only one component in here, we don't need to worry about the layout. Does that make sense?
Yep.
Okay, cool.
Exactly on the word you just highlighted there. Who's allowed to be used as XML tags there? What classes that we invent in our project are allowed to be used as XML tags? Ones that extend views?
Yes, because this is a layout file after all, so it's something that has to be laid out on the screen. So it has to extend view.
I have a couple of questions from the chat room here. And they seem to be dealing with the adapter pattern. For instance, why did you create another package for the adapter when there's already a task package? And also, when you're creating a list, are you going to have to extend the base adapter for every list that you create? And those seem to be good questions for the audience at large.
Okay. There's been a couple different questions about why I would create new packages. I mean, it's just an organizational thing. I just especially on a couple different projects that I've worked on that had a lot of different lists with a lot of different types of views for the items in the list. We've needed to have a lot of adapters, so I put those out in separate packages so I can keep all the adapters together and I could know where to go to look for adapters. It's not that big of a deal beyond just sheer organization. And then the other question was, do we have to extend base adapter every time? No, in fact, the homework that I'm going to assign you will point the way towards an easier way to do simple lists. The reason that I'm using base adapter, which is well, here, let's read the documentation for it. It says it's a common base class of common implementation for an adapter that can be used in both list view by implementing the specialized list adapter interface and spinner by implementing the specialized spinner adapter interface. So it's a very simple, basic adapter that you have to do a lot of code yourself. And the advantage for this class is showing you what kind of code that the adapter generally has to do. It has to do this type of a thing. It has to talk about the count, get specific items, get unique identifiers, and then construct the view for list items. So it shows you how an adapter works, and that's the advantage of working with the base adapter here.
Okay, and then I have a couple more quick questions. Somebody was confused about the orientation issue again. If you could maybe explain that a little bit more clearly, or a couple of people are confused actually. The other two questions are, what exactly is schemas.android.com/apk/res/android? And the third question is, how do we know which tags to use for each implementation?
So the orientation thing is, do I have a linear layout? I think I do in add tasks XML. So this is the screen. This is the view for the screen where you add a task. Linear layout either lays out all of the child views, the child components, in a vertical or a horizontal direction. So I can choose whether it lays things out horizontally or vertically. Like in this case, when I go to add task, things are laid out from top to bottom, so that's vertical. If I wanted them laid out left to right, then I would say horizontal. And what I've done here is go ahead and say that the orientation should be vertical, because what is going to happen is this task list item that we're about to create is going to be a linear layout. And I guess the question that Beth had was, why was it horizontal? And my answer was that it really didn't matter because we only have one child, and so there's nothing. It's just going to take up the whole view. But we do have to define an orientation for the linear layout, so I've just picked vertical. And I think the horizontal was actually left around in the code because I was trying to do a text view next to a checkbox, like left and right. I was having trouble initially setting up a text view laid out to the left of a checkbox, which was hard against the right of the view, with the text view label overlapping the text or getting cut off and not ellipsizing the right way and stuff like that. And then I poked around a bit and found this instead, so that's probably why I still had that orientation horizontal still hanging around in there in the code. But really it doesn't matter because there's only one child component. So hopefully that answers the orientation question. The other question was, what is this? The namespace? The XML namespaces are kind of you can look those up on Google and find out way more than you want to know. It's a way for you to have different, so the namespace that we have here is Android, and basically this doesn't need to be anything special. It's just a unique identifier that will distinguish it from other namespaces that we use in the XML file. And that allows us to do this Android : thing here for each one of those attributes, which is a bit verbose, but it allows the whatever code is interpreting this XML to pick out specific attributes and point them and check against, like somebody asked earlier, if we're going to be writing a DTD for this. It allows to make sure that these attributes are legal, and if they match against what Android is expecting for certain attributes to be there.
We need that because we're implementing a custom view essentially.
No, if you look at addtasks.xml, here's the namespace right up here. You need that because this Android : thing is special.
I see. I hadn't noticed it in the linear layout before, so now that makes more sense.
Yeah, probably. I just had it sitting up here at the top because it's just line noise for me, because I don't really care about that. I care about getting the view set up, so I kind of get it out of the way. But yeah, it popped down here to the bottom because this line got so long. But yeah, it needs to be in all of those XML files. Well, looking through the documentation on the Android site will let you know which ones are possible. So I was trying to use, like for instance, text view we've already gone through is a pretty common one. And then checkbox is another common one. I found this one by looking through Android source code, the source code for the apps that get shipped with the Android platform. But it's in the documentation too. You could go look up the Google documentation right now for check text view and look at it. So basically, the answer is by looking at. I think the best answer for me, it's not for everybody, but I think that the best answer is to look at source code as much as you can. But all these are up on the Android docs, so you can kind of poke around there and figure out, maybe find some new ones or see what's there. Or you could listen to screencasts like this and have somebody else tell you which tags that you'll use for creating different types of applications.
Thanks a lot, Tony.
I don't know. Was that too much of a trite answer? I don't know.
No, I'm just posing these questions. They're coming through the chat room from multiple users, and I want to make sure that they're addressed not just in chat but also through the course.
Cool. Yeah. So, yeah, this is what Android development's all about. It's figuring out which of these different options that you have. All right, but then you also have the option of creating custom tags and pointing them at classes, and that's exactly what we're going to do next. So we need to create a task list item that sits in this package structure. So I'm going to create yet another package called views and put a class in it. So I'll do that through this new class wizard here. The package I'm going to say is views. And we would do this just because I want to keep all the views in one place or have another separate hierarchy there to keep it clear where views are stored. The name needs to be task list item. That's correct, right? Yep, task list item. And the superclass is linear layout. And if I hit Control Space here, that will get completed to the class that Eclipse knows about, which is android.widget.linearLayout, which is exactly what we want. Finish, and now we'll have this new class, which will be the implementation of that view. So let me look at what we've got inside of here. So I'm going to treat this linear layout just as I would inside of a so sort of think of this as like in a model view controller type of a situation. We're kind of breaking down a little bit where the view logic is, because there's a lot of view logic that's taken care of by Android just by virtue of being a linear layout and having that XML file define what components we have on the view. So think of this class more like a controller, I think, and it should have the responsibilities of the controller. And the responsibilities that the controller would have in this situation are, I think, holding on to the components that you need to interact with, and one of those components is a checked text view. So we'll have a class for that, or a field for that, checked text view. We'll just call that checkbox, because this will work more like an HTML checkbox where you can have a label as part of the component. So I'm going to implement that guy, check text view, Android.widget. And I think the controller should also know about the data that it needs to display. So we're going to have a task called task. And we need to import that guy. And I'm going to collapse these imports, save us some space. And now Android or Eclipse is complaining that we need a constructor because there's a super constructor up the chain that needs some more information. So I'm going to hover over this task list item class that has the problem and say add a constructor that takes a context and an attribute set. So this is sort of a view into the innards of what those things that we define in XML need, or actually end up doing in Java code. You get this context because the view is going to be, as you will see in just a little bit, inflated, which means read from XML and turned into a specific Java class defined by the tag at the top of the view. And then so that context is important to tell the view some information about the situation that it's being inflated into. And then there is this attribute set, which corresponds to the set of attributes that we've defined in the XML. If I go back to the XML file, those things are passed in that way. Then the inflator deals with all those things, and we'll be looking at that in just a second. And then we need to send those variables up to the superclass of linear layout, and then that is pretty much all we need for the constructor. Now, what I also want to do here is allow someone to set a task on this list item, and when a task is set, we'll perform a couple different specific functions. So I'm going to hover over here and show you a nice little helper function in Eclipse that will allow you to generate getters and setters for a field, and you can see that there's a yellow underline underneath task right now which says that nobody uses this. Are you sure you want to define it? And one of the possible ways to fix that is by creating a getter and setter for task, and then we'll allow someone to set a task on this class through set task, and then we'll just have get task for what the heck. Click OK. Now you can set a task and get a task, and task is no longer warned, or no longer has a warning associated with it. So what we want to do when we set a task is not only keep a reference to that task, but we also want to manipulate the checkbox that we have a reference to based on the data that's inside of that task. And if I paste in some code here inside set task, you'll see that it all kind of makes sense. What we want to do is set the text of the task to the text of the checkbox to be the name of the task. And we also want to set the check state of the checkbox to whether or not the task is complete. And that is a new bit of implementation for the task, because the task that we have right now doesn't have a notion of whether or not it's complete or not. So what I'm going to do is, this is again, as some people have commented in the forums, I like to write code before it's actually defined and sort of work through that way, especially in a screencast situation. So I'm expecting there to be a method called isComplete on task, but there isn't one yet, so I can hover over this and say create method isComplete in type task, and it will do a little bit of work and then pop up the task definition here, and now we have a new method called isComplete, which returns a Boolean and tells whether the task is complete. So right now it's just using this default implementation, but now we want to have a notion of being complete, and we'll do that by defining a private variable here, boolean complete. And now you can set or you can sort of query the task to see whether it's complete, but you can't say whether it's complete yet. So we have part of the Java Bean type of pattern set up. The is complete, you use is instead of get for instances of Boolean variables as part of the Java Bean convention, which you can read about elsewhere. But we also need a setter for that, so I'm going to come here and say getter and setter for complete. You can see the getter name is complete, and that's already generated by that previous step that we did. But the setter name we want to be set complete, and I will click OK, and now we'll have a set complete function for us so that we can say whether or not a task is complete. And now we have an idea of completeness on task. And we just need to return it here, so return complete. And now a task knows whether or not it's complete. Now back in task list item world, the set task is set up. That's what we want to do. Whenever we set a task, is get the name, display it, get whether it's complete, and check the checkbox accordingly. Now there's one other thing that we need to do. You may have noticed that we don't have a reference. We don't ever get the reference set up. We don't ever link this checkbox variable up to the actual text checkbox component, or check text, or whatever it's called. So where you want to do that inside of a linear layout is there's sort of a life cycle to when a view is inflated and ready for all of its components are in place. So it may seem readily apparent to you that you'd want to do this inside of the constructor. I would want to say something like checkbox is find view by ID. In fact, here let me just copy in the code that we want, but I'll explain to you why you don't want to do it in the constructor in just a second here. So here's the code that we want. I want to go get a reference to this check text view that we have out on the screen with the find view by ID the same way that we do it inside of an activity, and it will use this android.r instead of the r that we have because once again we defined the ID of that using the text1 identifier that is used elsewhere in other Android applications. And that looks like this inside the code. That's a text1 ID against the Android R. And in any case, this code will get us a reference of the checkbox, reference to the checkbox. But the problem is that during the constructor, none of the child attributes are ready for reference yet. So you'll actually get an error here. And if we had more time, I could actually show you getting that error. But I don't want to. I'm just take it as a fact that you would get an error if you tried to reference any of its child views inside of the constructor. So what you want instead is to use a method that is called when the view is finished inflating, and that is called appropriately onFinishInflate. I just pasted in code here from 19 to 23. Make sure you call super always when you're overriding things, unless you know you shouldn't, and then we'll have that same code that gets us the reference. Now we have a reference to the checkbox, and a task list item can correctly set the text and set the check state for the checkbox when a task is set on it. So now that we've done that, let's go back to the task list adapter, because its responsibility, after all of this other responsibility is taken care of, is to get the view set up for a particular list item. So there's a lot of code that is going to need some explaining here. I'm just going to paste it in and then talk it through line by line instead of doing a lot of typing. So inside of getView, I'm pasting this code, this completed code that does some interesting things. So the arguments to getView are position, because the list view is going to want to get a view for an item at a certain position. ConvertView is an interesting thing that we'll talk about in just a second, and the view group called parent is basically a view that it's going to be rendered into. I think in some situations, but in our case, we're not going to need to worry about it because just in this case, you don't need to worry about this last item here. I don't really have more interesting information to give you about that because I always use this sort of setup in this situation where you don't care about this last argument, so there's nothing to talk about there really in our situation. But what we want to do is create a task list item view. First we need to import that guy, so I'm going to hover over there and import it. And now let's talk about convert view, because this is an important task that a list view needs to do, and that is, so say we had a list with like 1,000 items in it. If a list view created a list item for all of the views that would need to ever be displayed for that list, that would be a huge performance hit. It would probably crash the application because that would just be too much memory to instantiate all those views. So instead what it does is as you scroll through the list and list items sort of scroll off the end of the list and are no longer visible, they're actually recycled in sort of a situation where there's a pool of a few more than needs to be displayed at any one time, and then as new ones are recycled or list views sort of go off the end of either side of the list of the visible part of the list, either the bottom of the list or the top of the list, they're recycled, they're put back in that pool and then called back in when they're needed to be displayed again later. So that way the list view can make sure that it only instantiates like enough views to be seen for each list item. And the way that this situation works is that a recycled view for one of those list items is passed back into this getView method here. And if the argument is null, that means that there was not one that the list view wanted us to reuse inside of this adapter, so we will create a new one. And that's what we'll do here, which we'll talk about in just a second. But in the situation that a view is available for recycling, we're just going to get a reference to that view instead of instantiating a new one, and we'll honor the size of the pool of those list view items that the list view wants to create. So what I'm doing here is just figuring out which one I'm going to reference, either a new one or the one that the list view is passing for us to recycle. And then after that, I get a reference to the correct one. Then I will call setTask, which we've already seen inside task list item. We'll set the label and the checked state of that checkbox based on the data inside the list at a certain position that is also passed into getView. So then I will just get that data out of the task list. So hopefully that all makes sense. There's only one more thing to talk about here, and that is how to instantiate a view from XML. And that is done by using the inflate method of the view class as a nice helper method. And this is where we get that inflator guy. The inflator, again, is responsible for taking the XML for a view, parsing it, and then turning it into the correct Java class and returning an instance of view. So view.inflate, given a context, and the task list item identifier on the R class, which we also need to import here. And make sure you import the right one, com.O'Reilly Android Task Manager. Now it has an ID of a view that it will inflate from XML and turn into whatever class that is defined inside the XML, which again is a com.O'Reilly.Android Task Manager views task list item. And that is how we get the view for a particular item in the list. That was a big chunk of stuff to talk about too. Does anybody have any questions about that before I go on?
That was a big chunk. Somebody asked about the task being added to the task list item view, and is now the view hardwired into the model?
Yeah, so the view shouldn't know about its model generally. Sure, this is it should get information set on the controller. The view should be, manipulated by the controller instead of knowing about its model. That's why I say that in this situation, I think it's better to act as if this class is sort of the controller for the view, which is sort of living above it as a linear layout. It just happens to be that this they're really. I would say that in this kind of a situation, the controller is more tied to the view than the model is, because I'm thinking of this task list item as the controller, and it's the one that contains the reference to the model that the view needs to know about it. But there's not really a better way to do this. Where else am I going to have a controller in the application that is good at sending the information about a particular list item? That would be much tougher to do anywhere else. So this isn't breaking too many rules in any way that anybody should care about when it comes to like good separation in your model view controller type of a pattern. Hopefully that's a good enough answer, and we can. That's something that if we're interested in debating, we can take offline into the forums.
Yep. Okay. And then a number of people have asked for a quick overview explanation of inflate again, and exactly why you're doing what you're doing and where.
Okay. So, given that the task list adapter is responsible for a couple different things. First of all, listing having a reference to the list of all the things it needs to give to the list view on demand, and it's responsible for getting the view to the list view on demand. We need to, in some cases, instantiate the view, and because there's nowhere else to say what list item that we want to use, but rather than this adapter, because its responsibility is getting the view to the list view. There are easier ways of building adapters, which I'll show you, sort of point you to during the homework. But in this case, since we're responsible for getting the view, if there's no view to be recycled, we need to instantiate the view, and the way that happens is by saying that we want to use a view that is defined, or the layout of which is defined in this task list item guy, and we use but since we need to return an instance of view, we need to use the inflator to turn that XML into a class, basically, or an instance of class view. And that's what an inflator does. It reads an XML, figures out what class that is defined at the top of it, and instantiates that type of class, and then sets up all the attributes the way it needs to be set up. And then at the end, you've got a class of some type which extends view, and in our case, it's a task list item, which extends linear layout, as you can see here. And that is why we use the inflation metaphor, idiom, convention code right here. Does that make sense to everybody?
Makes sense to me.
The next thing that I need to do before we can start seeing some action here is to set up and wire up the adapter. So let's go back to view tasks activity. And as it happens, my pointer is exactly where we need to be. After we set the content view to main, and we've set up all the views in the app, now there's a couple of things that we need to do. So let's think about this. What we need to do is we need to construct an adapter, tell the list view to use that adapter, and then we need to, at some point in there, also tell the adapter where to get its data from. And where to get its data is from the task manager activity, because it holds that list of the tasks that we keep up there on the application, and we do that by using this get task manager application get current tasks. Except the problem is that we also need to make another step here, which is to change what this activity extends. So we went through that whole process of refactoring this task manager activity guy out last time so that we could call get task manager application. But now, because of the restrictions of single inheritance in Java, we have to get rid of that task manager activity inheritance and instead inherit list activity. Activity. Did I do better that time? I think so. Okay, so now I'm going to import that. Now, the payoff, the benefit that we get from doing that is that list activity is going to manage that list for us and make it very simple so that we don't have to worry about a lot of stuff like setting it up and finding it in the view. It's going to use that that magical view ID Android list. So it's going to do a lot of work for us, so it's worth it for us to do that, except that now we can no longer call get task manager application, which is a small payoff, I think, or a small trade-off to make. So instead, we still need to do the same thing. We need to get a list of all the tasks. I'm going to move this up to the controller and actually get rid of this method for right now because things are going to be a little more slick. And then on resume, we're no longer going to call show tasks. And then inside of the I said controller, I meant on create. Here's the dance that we're going to go through. First, we need to get a reference to the tasks, but we can no longer do it this way. We're going to, instead, I'm going to get a reference to the application. I'll show you sometimes this is a pattern that's used. I'm going to have a variable called app, so we have a reference to the application, which is of type task manager application, and we're going to task that out of get application that comes with the activity. And now this variable is not created yet, so I'm going to create a field called app, and it's of type task manager application. So now I have a reference to that guy. And off of that, I can get the current tasks, but I don't really need, and in fact, it's a whole better way of doing things, so to not even have a reference to that list of tasks inside this view task activity, because I don't really need it. All I need to do is give it to the adapter. So instead, I'm going to store a reference here to the adapter inside of an adapter field, which we'll construct right here, task list adapter. And that takes arguments of a context, which again, every activity is a context. So I can say this. And I need to pass up the list of tasks to manage, and that is found on app.getCurrentTasks. And now I need to import this guy, hover, import. I need to make a field, hover, create field. And now, let's see, what's the last piece of problem here? View tasks activity. I'm not sure why it's complaining there. I'm going to save. Oh, let me look one quick glance here. What order did I define these in? I have this different from my sample code, so I have the arguments reversed here. So I will just take this and move it to the end. Oops, this. Okay, now things should be kosher, and now we have a reference to the adapter. And now the next thing we need to do is to tell the list view which adapter to get its data from, and that is done by simply calling set list adapter, which is a method on list activity. And we can set that to the adapter that we just constructed. And now our list knows where to get its data. And I think that we are ready to go on and look at some code actually running. I'm going to clean up some of these unused imports here. So let's have a look here. I'm going to open this up in the emulator. And we already had 2 tasks defined, so hopefully those guys will get populated into our list right away, and no, they don't. So why is that?
So we're not saving our tasks yet, right, Tony? So are they being saved?
Oh, you're right. Yeah, sorry. They left memory. So we don't have any. Okay, that's right. Good. That scared me for a while. I was thinking ahead to next week when we're actually going to persist these so that they will stick around. But in this case, they don't. So if I come here and click Add Task, get Milk, our standard default Hello World task, it still doesn't show up. Okay, so I'm a little worried about that. Well, okay, so let's just take a step back and debug it and then figure out what's going on. So I'm going to put a debug breakpoint right here and debug the app. Okay, and now it's asking to switch in the debug perspective. I'll say yes. And once Eclipse wakes up a little bit from whatever it's doing, we should be debugging. I think I had it maximized last time. Yep, my Eclipse is chugging along here. Okay, inside debug.
Well, this is an unavoidable part of programming.
Yeah, debugging is a good thing to go through once in a while. Anyway,
Especially
man,
when you've written so much code.
Eclipse is really running slow. Yeah, especially when we've gone through a lot of code. So now I should be in the onCreate, and I'm getting a reference to the application. So what I want to do is step over that. So I have a reference to the application, which should be on this. And here we go, application. Inside app, we have current tasks, which is empty. Okay, good. That's what we expect after restarting the application. I think I know what it is. So here's the problem. What's happening is, okay, obviously it didn't occur to me first time, but once I restart the application, we have no tasks. So I can click resume from here, and we've got no issues with why we don't have any tasks in the emulator just yet. But once I add a task, and here's the line in my sample code that I didn't put in. You're right, it is the onResume. Somebody looked ahead. The guy who talked about the onResume looked ahead, didn't they?
Quite possibly.
Yes, because, see now, going into debugger.
The comment
I've got to stop this debugger.
The comment is the adapter as to be triggered in the onResume.
Yeah, so I have that I thought I didn't need to do that yet. And here I had a breakpoint from last week, which showed when we had text being input, but I'm going to get out of that deal. Thanks, Neil. Okay, now when I add a task and I go back here, I have to sort of tickle the adapter and make it say that we have new data in it, because there are more complicated ways to do that. But the way I'm going to do that here, which I didn't think I needed to do for this particular step, but I obviously do, is I'm going to build in this little, in onResume, I always want to get the updated set of tasks, so I'm going to build in this little sort of hacky way of doing this. Adapter dot force reload, which is just a method that I'm going to make. It's not any sort of system method. So now I'm going to force the adapter to reload itself whenever the onResume is called. So I'm going to hover over here, force reload, create that method since it's not there. What we want to happen inside that adapter is we want to call this method called notify dataset changed, and that tells any components that are using this adapter to this as the data provider that the data set has changed and that it needs to show its new data. So now, since that's being called onResume, I'm going to fire this up again and hopefully things will work correctly. Live coding, even when copying and pasting, there's still a lot of danger to live coding, but that's all right because we're living on the edge here. There's excitement.
It's extreme programming.
That's right. It's extreme programming. It's extreme programming in a real sense too, because I'm getting so much help from the audience, my pair programmers. Okay, so now we have tasks displaying. Great. So we can add more tasks like there's a task that I forgot. So now we have multiple tasks displaying inside this list. Okay, that is the steps for this, for completing this part of the process. And we have like 3 more to go, but I think they're a little bit shorter.